Hi there. So today I want to talk about sorting numbers in scientific notation, and I will look at some, not all, but some of the problems that you had off the most recent homework. And so we'll work through those and I'll highlight some of the issues that I think come up. So before I do that, I just want to look at this number line. I put these numbers -1, 0, and 1 on it, and those numbers split the line up into 4 regions. And I want to think and talk about what kinds of numbers in scientific notation land in each one of these 4 regions. So how about out here, the positive big numbers? I'd like you to give me a number in scientific notation that lands in this region on the form. So whatever you typed, it should be a positive number times 10 to a positive power, because that's how you become a big positive number, like 7.2 times 10 to the 23rd, or anything else like that. So now let's look at this region in between 0 and 1. I'll call those positive small numbers. So again, in scientific notation, go to the form and write a number for me that lands in there. So your number, whatever it was, should be a positive number times 10 to a negative power. That power of 10, that negative power, is what tells you it's a number that's tucked in close to 0, that's small. So that would be 6.881 times 10 to the -15th would be a number very close to 0. How about this region in here? When I get to negative numbers, small and large can get a little bit confusing. What's smaller, -3 or -3 billion? So I will tend to say close to 0 or near 0 and far from 0, just to avoid that ambiguity. So it should give me a negative number that's tucked in close to 0, essentially a little tiny number on the form. So these, again, the power of 10 is still going to be negative. That's how we know a number is close to 0, but now they're negative numbers times 10 to a negative power. And finally, we have this region out here, our negative far from 0 numbers, like -73 billion. So why don't you give me a number that would land out there? My example might be -2.11 times 10 to the 17th power. So that's our number line. I'm just going to leave this image down here for the entire duration of the problem, because that kind of gets us our bearings. So here are some of the numbers off of the sorting problem from the homework. And in order to sort these in scientific notation, we're first going to have to write them in proper scientific notation. And why? Well, look at those first 2 numbers there. The second one looks larger because it's a bigger power of 10, but it's not really a 10 to the 16th sort of number because it has all of these funny decimal places here. So let's write that one in proper scientific notation and then look at what was done. This first one, we don't have to do any work, 3.54 times 10 to the 12th. But the second one, when we move that decimal place 4 places over by stealing 4 powers of 10 from the 16, we see that this second number is actually 1.2 times 10 to the 12th. So the second number is actually a little bit smaller than the first one. And I've done the first several numbers here for you. This one, we are making the number part smaller, so it's giving up 2 powers of 10 to the exponent. So the power of 10, we're adding 2 to that. Similarly here, we're adding a power of 10 to the exponent because the number part is getting a digit smaller. This became 3.12 times 10 to the 13th. And I just want you to take a moment and look at this one. -125 times 10 to the -7th. You tell me what that is when it's proper scientific notation on the form, because negative exponents are always annoying. Okay, what did this one become? Well, 1.25. So this number got smaller by 2 digits. So we had to add 2 to the exponent. -7 plus 2 becomes -5. And I've done a couple more on here. 7.84 billion. Billion means the same thing as times 10 to the 9th. So you can just take out the word billion and replace times 10 to the 9th. This is 700. I think I said 7.84. It was actually 784 billion. So this becomes 784 times 10 to the 9th, or in proper scientific notation, 7.84 times 10 to the 11th. I think I only had one more that needed to be fixed up, 923 times 10 to the 2nd. we're going to move that decimal place over 2, make this 2 smaller, add 2 to the exponent to get 9.23 times 10 to the 4th. So there we go. We've turned these all into proper scientific notation. Now I want to color code them by which region they belong in. You may not want to do this by color coding, but you want to go through and look at each one and say, is it bigger than 1? Is it between 0 and 1? Is it between 0 and -1? Or is it out past -1? So these two here are out past -1. These three are between -1 and 0. And I only have one number that's between 0 and 1 on this list. And I have a whole bunch of big positive numbers. Having done that, I'm going to start to sort them. And I'm going to start by looking at the power of 10. And I know if one number has a larger power of 10 than another number, then the one with the larger power of 10 is one that's farther from 0. So I can look through the blue ones. Mostly the power of 10 is enough to tell me. These two, those two that we looked at the very beginning, have the same power of 10, the 10 to the 12th. So in that case, I look at the number part. 3.54 is bigger than 1.2. 10 to the 11th, 10th, 4th, great. So I've gotten through all of those. I only have one number between 0 and 1, so that would certainly come next. And now I have to look at my yellow numbers. And I've got a couple yellow numbers on here that I'm staring at. There's -1.24 times 10 to the -4th, and there's -5.78 times 10 to the -6th. And one of those two is going to come next. The 10 to the -5th number is in between them, but I have to decide which of those two comes next, which of those two is closer to 0. And I want you to think about that and answer on the form. So the more negative the exponent, the more zeros there would be between the decimal place and the number when you wrote it in scientific note, when you wrote it in regular notation. This would be -0.0000578. It would have more zeros in it than this, which would be -0.000124. So the more negative the exponent, the smaller the overall number, the closer you are to 0. So as I move below 0, I first get -5.71 times 10 to the -6th, then the -5th exponent, the -4th, and finally, I'm going to pick up these large negative numbers, the numbers that are negative and have 10 to a positive power. And I have -4.54 times 10 to the 3rd, followed by -4.36 times 10 to the 5th. So that's how we sort numbers in scientific notation. I always like to keep my 0, 1, and -1 on there as benchmarks, kind of way signs to tell you where you are. You don't have to worry about writing 0, 1, and -1 in scientific notation. You can just leave them as they are. Thank you, and see you in class 6.